So, hello and welcome to the Code Maven's meetup group and Code Maven's channel if you're watching it on YouTube. My name is Gabor Szabó. I usually teach Python and Rust at companies and also introduce test automation and CI and the area. And I also think that sharing knowledge is extremely important among high-tech programmers and people working in the high-tech industry. So that's why I'm organizing these meetings, these presentations. As you can see, it's being recorded. It's going to be on YouTube. Please like the video and follow the channel. Below the video, you will find a link to information about Eyal and about the content of this video. And I would like to welcome everyone who joined us in the live meeting, and especially Eyal giving us the presentation. So now it's yours. Please introduce yourself and share the screen as you feel fit. And welcome.
Thank you. So I'll share the screen. So this is a presentation about Async.io. It's like a takeoff on a presentation I did like I think 2 years ago, or maybe 3 years ago. A bit about me. So I've been developing for more than 15 years and working in Python for like 5 to 10 years. And currently I lead the data team in Scenario. See, that's me. So you can find me in the links. And if you're interested, we're also hiring. So you're welcome to try and join. And we're looking for people that work in Python and data is their passion. So today, what I'm going to do is I'm going to go through a bit about what Async.io is and try to give a real-world example from things that we do. And then we'll try and talk about some advanced topics regarding Async.io. And so that's what we're going to do. I think it's important that you guys feel free to step in and ask questions if you need. And because there's going to be a bit code and some topics, and maybe hopefully it's going to be all clear. But if somebody has any question, then feel free to jump in. So first of all, what is Async.io? So Async.io is a style of concurrent programming in Python. So why do we need it? So you can think of wanting to do multiple things in Python at the same time. So a simple way to do it is using a fork, right? So you can run multiple Python processes at the same time. So the OS handles the concurrency, and you can actually use multi-cores on your machines. And the problem is that you get duplicated memory because each process has its own memory space, right? And in order to communicate between the different Python processes, you need like OS level communication. So pipes and files and other ways of multi-process communication. So you'd say, okay, maybe we can do it some other way. So there's also multi-threading in Python. So this is nice. So you can create new thread, and it looks like you can run multiple things at the same time. But then there's GIL. So GIL is the global interpreter lock. I know there's an agenda in Python to try and remove it, but for now it's there. And GIL prevents multiple commands of Python running in the same process at the same time. So OS concurrency for threading is done when you do things like accessing files or network, or anytime that you give access from your Python commands into the OS. This is done. It's something you don't do implicitly. You do it. You can't do it explicitly. You can only do it implicitly by accessing something or doing something that requires OS interaction. And there's Async IO. So what is Async IO? It's an IO event manager. Okay, and it helps you manage states. So you can have multiple states of your system on the same thread, and you can actually explicitly manage the context switching. So you can say, I want to work on multiple items. These are the multiple items, and I want to work on them. So if we look at high level at what the options are for multiprocessing, say we have like multiprocesses. So you can have concurrency and you can use all the CPUs, but you can't run many processes on the same machine because each uses a full CPU. So maybe 1 to 10 CPUs and processes. And you can use generally the standard library blocking components and synchronization tools. And then if you need something that's maybe a bit higher on the scalability, you can use threads. So you have a single process, and Gil is protecting you from doing things between threads, which touch memory in intrusive way. And but the problem is that you let the OS think your code, and you can't really control it manually. And then there's Async IO, where you can actually handle multiple thousands of scalable small components. You call them coroutines, and it's in an application level. So this is what we're going to look at today. We're going to see how it works, and how you can control it. So, like every other program in the world, there's the hello world, like in for Async IO, right? So there's um, let's see, can you see my cursor? I think you can. So there's a regular hello world, and there's the one with Async IO await. Okay, but this program is not really helpful, right? Because it doesn't show anything that's important for us. So what do we want to do with Async IO in the real world? So we want to use it for handling multiple heavy IO processes. So like maybe database accesses, or multiple web requests, or file sharing, or accessing many IO components at the same time. And you can always use Async IO using multi-processes. So you can have maybe in a cloud application, you can have multiple pods, right? But also you can run it on multiple processes and have the ability to use multiple CPUs if needed. But the downside of Async IO is that it's almost a different programming language. It looks like Python, and the constructs are very much like Python, and you just use like a few more keywords, but it's very different in concept, because each coroutine, the functions that you call with await, they have to be short enough to allow multiple contexts to run together. So you mustn't use long computations. You can't block the event queue. Okay, just like in IUI application, you don't want the main loop to be blocked. And also, you can't use general purpose OS blocking commands like create connections for socket, or select, or sleep. So you have things that are async IO specific. So you even have like different libraries that you can use in async IO. So if you usually use requests, I suggest you try use HTTPX. It has better async IO behavior, fast API over Django and Flask, MPG instead of PsychoPG, etc. Okay. So if we look at Async IO at the main building blocks, what we have is we have the main Async IO run command. So what it does, it receives in a sync way, it receives in a sync context, it receives a coroutine, something that is run on the async IO loop, and creates a loop and runs the coroutine in it. And usually this is how you do the entry point into async IO context. Okay, and then you have the coroutines. These look like you define async, def, and a function, and this creates a coroutine. Okay, and coroutines you can run either using the main loop or create a context, a task, using the async IO create task. Okay, and also when you want to wait for something to happen and you want to release the context, so you run await, call await in the coroutine, and then you await for the context itself awaits until the async context is finished, and then returns the control to the main loop that calls this. Okay, so I'm going to show you guys an example of a small program. And so what this does, this is a synchronous program. It reads from S3 and then queries some database, right? So we have like two contexts. One, this is the first one, this is the second one, and they're not dependent on each other. You can see it just gets a file and then just runs a query. And assume we want to try and do this together because we want to have the context returned with the content itself, but we don't have some kind of connection between the two contexts. So what you can do is you can move to async IO, define this as a coroutine using the Eyal Balla async library, and using async PG, create a coroutine from the query of the database, and then you can use gather to run the two coroutines together. Okay, independently one from each other. So when the execution of the query runs, the return of the items and the body and of the file is done. This is done asynchronously, and while waiting for the IO, the context is continued to the other part. Okay. Questions? Great. So more options. Async IO also supports context managers. So this is very convenient because you can create, for instance, in this, you look at the bottom part here, I had to connect and then close using finally, but I can also create a context manager from this and open the connection. When the context manager exits, close the connection so I don't have to use explicit exception handling. And also async IO supports iterators, so you can use like generator way of controlling small parts of the code one after the other, and using async iterable. So these are patterns very known in Python, and you can also use them in async context. So now I want to show you guys maybe a problem from our day-to-day work. I'll present the problem first. So what we want to do is we want to do some integration, which reads data from an external source and then enriches it, okay? Gets information from maybe a database and then adds to the context from the external source, and then writes the results into our database as entities, okay? And I think the main issue here is that maybe we have multiple customers. Some are small, some are large, and customers have maybe tens of thousands of entities. So there's a lot of reading from the external source, and also maybe a lot of writing and reading into the database. So we have a lot of IO, and this actually fits very well the async IO concepts. Okay. So what do we want to do? We want to call something once in a while and go over each of the customers, get the information, and then update with the enriched information. into our database. Okay, so like a naive implementation would be something like this. You define all the bootstraps needed, and then you get the list of customers, and then for each customer you do the enrichment. So you get the settings and you run the enricher on the information, and then you per customer you get the information from the integration system and enrich it and write it into your database, right? So this is nice, but the problem is that when we look at this, so this runs per customer. So that means that until one customer is done, the next customer doesn't start. Okay, so if we have small customers and large customers, then we have a problem that small customers are impacted by the size of larger customers, right? And also, once we have something that's bigger than the total Chrome time, then it doesn't actually, it's not actually up to the time, it's called time. So system is not up to the functionality according to the time constraints that it's supposed to run it through. So what can we do? So I think the first thing we can do is separate it per customer. So we can have some kind of injection of the customer ID through a queue and have the system run only per customer. So it reads the information from the queue, gets the customer ID here, and then runs the same thing just for a specific customer. So how does this help? So what we can do now is we can scale out. So we can have multiple instances of this specific code run together, each on a different customer. And assuming that they're not dependent, then small customers are now not impacted by the size of large customers, and the number of the time that you want to run this is at most the time of the biggest customer, right? So you can scale out as much as you want, and the time that this whole process takes is the time of the biggest customer. Okay. So till now, we did not touch anything that's async IO, right? So we just used like simple design patterns that allow scaling out of loops. So now let's try and use async IO to improve the performance of this whole loop. So what do? We create a coroutine and run it using async IO run. And this coroutine is very much similar to what we ran before, except that now when we look at what happens inside the run for customer, this looks a bit different. So what do? First, we create, we run through the pages, okay? And when we want to enrich the items, we create batches of coroutines, and then we run them together. Okay, so here the coroutines are created according to the number of the integration items. And when you enrich and read the information, each batch of the coroutines runs together. So you can wait for, so they happen together and wait only for the IO for each of the items. Okay.
Yeah, I have a question, and just I'm sure if I can interrupt you mid-sentence.
Yeah.
So as far as I know, in async IO, it is enough to mark the function itself as async. You just wait for it. So I'm not really familiar with the syntax like here. So why do we need to async this as well? I'm not really sure I understand. Or
So
maybe just
what
a
we're doing
syntax
here
thing.
is we wait for each of the pages. So this is an async iterator, right? But this is the coroutine which returns an async iterator. And when you what each of these pages contains items. So you want to enrich each of the items. So you create coroutines for each of the items to be enriched. And when you run them using gatherers, because when you run await on something, okay, this makes the higher level function wait till it's done. Okay, this is a way to synchronize async context. Okay, so here you synchronize multiple async contexts using gather.
I see. So you just gather all the chunks that you have and you create them with the async iterator rather than just give a big function and just async on that, right? That's what you
Yes,
meant.
because you want to split your context into smaller processing units. Each of them may be IO bound. So together, the IO would run together on each of the in parallel on each of the items.
Got it. Thank you.
Okay, so now, like I said before, so enrichment happens in parallel, but still you can scale out. So you can have the multiple services, and so the total performance here is not blocked, and also small customers are not impacted by the large customers. Okay, so some other things you should take into consideration. So I think the first thing is exception handling. So when you create async contexts, you sometimes need to handle exception in the top level. So when you do that, you can register a manual exception handler. So you get the main loop and set the exception handler, and you can handle the errors from that are created from each of the tasks separately, because if you don't do that, then the async IO context would behave. It would exit on each of the when one of the subcoroutines throws an exception into the main context. Okay, so sometimes you want to wait maybe for the last one, or have some other behavior that is specific for your system, and you can do this way. Specifically for gather, you can have two ways to handle exceptions. So you can do it inside each of the coroutines like I did before, or you can ask the gather to collect all the exceptions from each of the coroutines, and then you can handle errors together. For instance, if you want to have some retry mechanism, then this is a good way to do it. So you gather all the errors, and then you can retry all those that failed, or decide to do whatever you want to do with those that did not succeed. Regarding testing, so I think if you look at this coroutines, what I want to test here is I want to test maybe functional response, okay, something like a happy path and maybe an exception to test the raise for status. So the important part is to mark your test as PyTest mark async IO. So this allows you to run test in async context. There's like HTTPX gives HTTPX mock, so you can use that, and then you can inject the response here, for instance, and test your happy flow. And also, you can always use PyTest raises like you did before. And assuming you marked as async IO, you can test the flow of async in the exception flow. Okay. Sorry. What you can also do is there's async mock, like unit test magic mock. You can mock coroutines. So here's an example of how you mock a coroutines and test it. So this is something that's nice to know, and I think it's very valuable when you're testing and mocking coroutines. I think that today the default patch returns in async context or magic mock or an async mock according to the type of function that it gets. So if this is the coroutine, then this would return create this as an async mock, and if not, it'd be a magic mock. Okay, according to what is needed. Something else that's very important for developers is the ability to debug. So async.io gives debug mode. When you run with the environment variable, you get also tracebacks on async functions when they're not awaited. So you can find out where this happens and when. And also this monitors thread safety. So when you behave, something in your system behaves unsafe regarding the different coroutines and the memory they touch. So you get errors in your logs. And also this helps debug slow coroutines because async.io is very sensitive to having coroutines and long coroutines blocking short coroutines. So this actually helps you understand better the flow of your code once you use async.io. So this is how a slow log looks like. So if I do something very slow, you'd get like a log saying this has taken too long. Okay, so you would know that you want to look at this function. Also, something you might want to consider is having something that solvers running in your context, in your services. So AIO debug allows you to log slow callbacks inside your production pods. And this, you can enable specific callbacks when this happens. And this is really great because this has almost no performance impact on the actual services, and it allows you to understand better how your code behaves in production. Okay, great. Also, something you can do is you can monitor each of the different tasks. There's async.io get all tasks and current tasks, so you can run a coroutine once in a while to understand what is running and get the stacks and understand the behavior. Okay. So this is about it. So I went over the async.io concurrent programming framework. I think we saw a real world example and understood a bit how async.io behaves in something and why we'd want to use it. And also we looked at some debug, testing, and exception handling tools. And that's it. Questions?
Can I? Do you hear me?
Yes,
Yeah.
we can hear you.
Oh,
Go
hi.
ahead.
Yeah, hi. So you touched a little bit on it, but I'm when I'm doing something that I call it like a project that develops into something a little bit bigger, I find myself sometimes I just get lost. Oh, I can't verify myself that I actually control all the coroutines properly. Because many times I have queues that feed one another, like I have some streaming and then some queues and something like that. And so you touched a little bit on that and how you monitor that, but can you expand a little bit? Like how do you deal with that? Because I just afterwards I go back and I just print constantly and I check the timing and I waste a lot of time on that. And I feel like maybe someone more experienced has a better solution.
So I think when you, I think that the first thing is to build your software, like in, even though it's async, you need to build it like a top-down architecture, understanding which parts are calling the other parts, and making sure that when you synchronize correctly. Okay, once you do that, things are easier, I think. So you need like other considerations in software development, you need to have a solid design as a beginning, right? And then you can use something like the task monitor right here. So you can add this as something that you can call within your code. And this actually helps you understand the different coroutines that are run at the same time, and can help you understand, together with the slow coroutines, understand the impact of each of the different coroutines running. And I think that when you say I want to understand, so you have some kind of a problem, right? You have maybe something that doesn't get the ability to run at all, and you don't know why. So the reason to these is probably something is blocking the main loop, right? It's too long. So you'd get messages on the slow callbacks, and then you would see this in the running tasks and understand the context of how it ran. So does this make sense?
Yeah, it's something on that area. It's mostly that when the project gets big enough, I have design pattern for code that I know that I follow that helps me. I come again to a code that I didn't touch for a year. I know, like, okay, this is what I do in order to actually add a new feature. But somehow when I when I develop with async, unless it's something, the whole development many times, like if I want to change something in the future, I find myself having to go very deep into the code. Like I don't or maybe I just don't know how to do a design pattern well, and for my experience, just affect the stuff that change in their behavior from something that's run synchronically to asynchronically had forced me to change my code way deeper than I wanted. So this is what actually I'm curious about. This is the pain that I experienced. Did I make myself clear? Like the something changing in the future. I want to add something, and this thing now is, let's say I have some. I'm scraping some information, and I'm limited and I want to do it in parallel. And I have an existing project that was not that so far didn't assume anything that has to be in parallel because I had a different data source that I used before, and it was way faster. So now
So I think what you would do is you would add maybe an async IO context to part of the code, right? And then run it maybe with async IO run, and the rest would remain synchronous. So you can limit the extent of what you're looking to. And also, as always, be sure to test the specific part as a different library that you're calling, and treat it like one. So like a different code component, a different part of the code, and put it somewhere that's self-contained, and maybe that can help.
yeah. So what you're describing is how I solved it, but I was not actually. I was asking myself, like, if I had to go over the project again, saying, oh, maybe in the future I will have some asynchronc part. Actually, I want to actually prepare my code for the possibility of something as running in async in the future.
So I can tell you that we needed to move from synchronous code to async code in our company, and this is quite a big migration, because as I described in the beginning of the talk, using async IO is like something very different than the design of a synchronous program. So I don't think I have like anything that I can say, well, if you write a synchronous program and you want to prepare, do this and that, because I think that you need to look at it in a very different way, writing async code and sync code.
Okay. So it sounds like you went through the same problems I had. So
Yeah.
at least we suffered together.
Suffering, sharing is always good.
Yeah. Yeah. Thank you.
You're welcome. Anything else?
Yeah, I have a question. I'm using a lot of third-party libraries, Fast API, SQL Alchemy, like that. And they sometimes hide the implementation of async IO. And I always wondered, because I just believe it works well, is there any way to query the event loop so I know like what's running right now? Is it even possible? Is that something that Python hides from us completely?
So this is like a way to query all the tasks that are running in async IO.
Oh, all right.
And also, there's a library I did not talk about here, and it's called AIO Monitor. So you can look into that too. And it's very nice. So you can try that too.
All right, cool. Because you talked about the timing, so I didn't know if there are other concerns, but AIO monitor, that's cool. We'll check it. Thank you.
Okay, so I think we're done. Thank you guys for listening, and you can reach me this email or LinkedIn, and also there's a GitHub project with this presentation and all the code samples together. I think I sent it to Gabor last time, but I can send it again, and he can spread it out.
Yes, that would be a good idea. I think I'm going to include it in there is this web page about the presentation, which will be linked from the video, and then on that page you'll see also I include these links as well. Also
Great.
your LinkedIn and your and the link to your that GitHub page or GitHub
Okay, great.
repository.
Can I ask a
No more
question?
questions, then thank
Can I
you
ask-
very much. Yeah, thank you everyone for participating and
I
asking
think there's one
questions.
more question.
Oh, I
Oh.
asked if I can ask chit chat questions.
Yeah,
Like
go ahead.
it's not, so you said you have a company, like what your company does, and can you elaborate a little bit more? Or
Sure. So scenario, we do security for healthcare. So we give hospitals tools to understand security posture and attack detection. So we detect malicious content and attacks on hospitals. And I think because hospitals are very sensitive, so we need to handle like a very high scale. We do with passive network inspection, and so we handle like quite a lot of information in our cloud. So we need to use tools, and also using async IO helps us scale out and handle things as we need. I hope that that answered.
Yeah, no, I'm just curious. Like it's very far from my my expertise. I'm a data scientist, and I came across I think when some of my projects needed some a boost.
Yeah.
You're looking also for data scientists? I'm not available now, but in about a month or two.
So I think data scientist is not something that we're currently looking for, but you can actually look at the company career page. There are several positions, and we're expanding, and it's a good time, I think,
All right.
for
I'll check
us.
it out. All right. Thank you.
Okay. So thank you very much. Thank you, Eyal, for the presentation and for all the questions, people. And everyone who was watching, please again like the video, as I told you, and follow the channel. And if you would like to present at one of our meetings, then please get in touch with me. I would be happy to provide the place for people to share their knowledge. Thank you very much. Goodbye.
Bye-bye.
Bye bye. Thank you.
Thank you.
Thank you. Bye bye.